Coding some VOD.
Letters combinations of a phone number. Let's analyze this problem. In this problem, we have been given a string that contains digits from 2 to 9, and we need to return all possible letter combinations that a number could represent. And kindly note that the string contains digits, and we need to create the combinations based on the mapping of those digits. Let's consider example 1. In this, they have given the digits 2 and 3 as an input, and in output combinations has been formed on their mapped digits. In the input they have given 2 3, so 2 is mapped with a b c and 3 is mapped with. Now you can observe in the output that the combinations are starting from a, then there are combinations that are starting with b, there are the combinations that are starting with c. It means that you are having choices, and when you are having choices means somewhere or the other recursion will be used. And since there are a number of combinations that has been generated, it means backtracking is also used. To understand the concept, you can consider it as that suppose you are having an empty string initially, and in this empty string now you have the choice to start with a b and c. Now if you are taking the path for starting the combinations that can be generated by selecting a, it means you will explore all the combinations associated with a in the mapping of element 3. Now, at this point, you will try to analyze A with D, A with E, A with F. And in the leaf node, you will get the required combination, that is AD, AE, AF. You can observe that you have AD, AE, and AF in the output. Similarly, all the combinations will be generated for B and C. This I have drawn to just show you the glimpse. We will be definitely analyzing this through the recursion tree. I will be showing you there that how backtracking is used. For now, you can keep in mind that for exploring this in horizontal way, in this way, we will be actually iterating here, and for exploring in downward way, we will be using the recursion. We will be actually updating the index. We will be actually updating the index by +1 for going into depth of the recursion. Kindly note that at this point also, we will be using the iteration. Now we will be diving into the recursion tree for better understanding of this problem. Initially, we have this scenario. We have the digits 2 and 3, and we will be storing all the combinations associated with 2 and 3 in this result vector. Now let's come on to this. We are having 2 and 3, and in the 2 and 3 you can observe that 2 has an index 0 and 3 is having index 1. And their mapping is also defined that 2 is associated with mapping A, B and C, and 3 have the mapping D, E and F. And we are currently standing at the function which has an empty string and an index that starts from 0. Let me mention here that this is our current string and this is representing our index. Therefore, at index 0, we have digit 2, and in the digit 2, the first letter that we have is A. So, we will select A and explore associated combinations with it. Now, I have updated the string with A and updated the index with incrementing by 1. This is representing 1. Now, since the index has now changed to 1, it means now at digit 3, which has the mapping D, E, and F, we will be exploring all the combinations that can be associated with element A in the mapping D, E, and F. Therefore, we will now select letter D. The string will become AD. and the index will become 2. AD represent our first combinations, and it means that we are reaching the base condition. Therefore, the base condition here is that if index becomes equals to the digit size, then we will be adding the combination to the result, and then we will be returning back to explore more combinations. Therefore, we got AD. Now we will be backtracking. After coming on to this position, now it's time to explore the letter E, explore E, and we will get A. And again the index will be updated to 2. Since this is again the base condition, we will be updating our result with A now. Now we will be again backtracking for exploring F, and we will get the new string as AF with updated index 2. This is again the base condition. We are reaching the base condition, and we will update the result by AF. Now we will backtrack since now nothing is left to explore. We have explored this F, and we will backtrack again at the point we were having an empty string. And since again you are at index 0, it means you will be exploring for 2, and at now 2 you have explored letter A. Now it's time to explore for B. When you will explore for B, letter B, we will get the following tree, and we will update the combination BD, BE, and BF in our result vector. That is BD, BE, and BF. Since all the combinations that was associated with B has been explored, now we will be backtracking. Now again we are at index 0. Therefore, the only choice left with us to explore is with element C. Therefore, we will be exploring the letter C, and we will get the following recursive tree. And we will be updating CD, CE, and CF in the result. And since all the choices has been explored, now we'll be backtracking, and we'll on backtracking we will be reaching at index 0 again. We'll find that now there is no choice left to explore because we have already explored the element C. Therefore, this is our required result. Now let's try to understand the code. We have been given a function that is a letter combination, which is accepting string digits as a parameter and returning vector of string. Therefore, we have created a vector of string named as a result, which will store all the combinations that will be generated through the recursive function. And then we have created this for edge case. In case of empty input, it will return the empty result. Now, at this point, this is an important point to understand that this has been created a mapping of digits to the letter. And here, since we are following the zero-based indexing, we have assigned the zeroth index with empty string, and one index was assigned again the empty string because it was given in the question. There was nothing assigned to the digit 1. And we have created this current string which will help us to generate the combinations, and then we are calling this solve function, which is accepting digits mapping current as a parameter. It is the zeroth index we are starting with, and finally after we will get all the combination, we will be returning the result to this letter combination function. Now let's come on to this solve function. And the solve function, this is the base condition that we have. It says that if index become equals to the size of the digits, in that case we will add current combination to the result. After that we will be returning. Now let's come on to the recursive case. This is the recursive case. In the recursive case, we are first trying to get the letters corresponding to the current digit, and then we are iterating over the letters for the current digit. In this part, we are adding letters to the current. It simply means that we are including the current letter in the combination. And then we are recursively diving to generate more combinations, but keeping in mind that we will be updating the index by +1 and we will be sending the updated current value. And then we are removing the element through pop back from the current. It is just like we are backtracking while keeping in mind that we are excluding the current letter from the combination. And at the end, thank you for watching this video.
Like, comment, subscribe to Coding Samvad.